Today we are going to be looking at our Learning Target 5 from Unit 5, which is I can find distance between 2 points using the Pythagorean theorem. So when we see 2 points on a graph, as we do in the diagram here on the page, often people want to just try to count the boxes along the way. However, if we look at that, they're not full boxes that the line is being drawn through. So unfortunately, that method does not work. But if we take what we have been learning with the Pythagorean theorem and we create a right triangle to where our diagonal line that we are looking for the distance or the length of is our hypotenuse, then we can use our Pythagorean theorem to find that distance. So we can use the Pythagorean theorem to find the distance between 2 points. So if we look at our diagram here, my one leg is 3 units tall. My other leg is 4 units across. So using my Pythagorean theorem, if I take the square of my 2 legs and add them together, that should equal the square of the hypotenuse. So 4 times 4 is 16, plus 3 times 3, which is 9, equals c squared. 16 plus 9 is 25, equals c squared. And then we need to take the square root of both sides. So that lets me know that my distance between my 2 points, my hypotenuse, my c, is equal to the square root of 25, which is 5. So the distance between 1, 2 and 5, 5 is 5 units. So if we look at our first example here, we'd like to find the distance between -5, 6 and 3, 2. So if I draw on that line, I then want to make a right triangle. I can either do this by drawing a vertical line down and a horizontal line across, or I could draw my horizontal line across and my vertical line down. Either way, I have a right triangle that has been created. So if I find out the length of one of my legs, 1, 2, 3, 4, and then the length of my other leg, which is 8, I can then use my Pythagorean theorem, a squared plus b squared equals c squared, to find the distance between those 2 points. So 8 squared plus 4 squared equals c squared. 8 squared, remember, is 8 times 8, which is 64, plus 4 times 4, which is 16, equals my hypotenuse squared. 64 plus 16 is equal to 80. And then I need to find the square root. And c equals approximately 8.9. So the distance between -5, 6 and 3, 2 is approximately 8.9 units. Okay, the try it. We are looking for the distance between 1, 5 and 5, 2. So again, I need to create a right triangle so that I can find the distance between those. The one leg of my triangle is 3 units. The other leg of my triangle is 4 units. So 3 squared plus 4 squared equals c squared. 3 squared, 3 times 3 is 9, plus 4 times 4, which is 16, equals c squared, and we get 25 equals c squared. If we take the square root of both of those values, we get c is equal to 5. So our distance is 5 units. So with our examples here, we are going to first have to graph our points, and then we will find the distance between them. So point A is at -6, 4. So right about there, and we're going to label our points. Oh, got it. Just A, not the image of A. And then B is at 5, 1. So right there, and we are looking for the distance between those two. So I'm going to create my right triangle. Which gives me a leg with a side length of 3 and a leg with a length of 11. So if I plug that into the Pythagorean theorem, that gives me 3 squared plus 11 squared equals c squared. 3 squared, 3 times 3 is 9, plus 11 squared, 11 times 11 is 121, equals c squared. So that is 130 equals c squared. And 130 is not a perfect square, so we know we're going to have to round. We'll just round to the nearest tenth, and that gives us approximately 11.4 units. So the length from A to B is approximately 11.4 units. For number 2, we're finding the distance between C and D. C is at -2, 6. 1, 2, 3. Okay, and D is at -2, -2. And now every year, this example, I love it, and we aren't in class necessarily talking about this. However, every year when I give this problem, without fail, I have students try to create a right triangle, and it never quite works out the way that they want it to, because they are overlooking a very important element, is that this is a vertical line. This is not a diagonal line. I could create a right triangle, but I don't need to, because I can just count from point C to D the number of boxes that I cross. So 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units. So make sure that you are not just automatically going into the Pythagorean theorem, because it might be a problem where it's unnecessary to use it. So just be sure that you're analyzing every problem as you do it. Alright, so if we're looking at our last example here, we have our GeoCity, and we are looking for the distance between, in our first example here, between the school and the park. So the school is our red schoolhouse, and the park is the tree. So if I am looking for the distance between those two, again, I need to create a right triangle since I'm looking for a diagonal distance. And so my one leg is 4 units long. The second leg is 6 units long. So if I plug that into my Pythagorean theorem, a squared plus b squared equals c squared, get 4 squared plus 6 squared equals my hypotenuse squared. 4 times 4 is 16 plus 36 equals c squared. And 36 plus 16 is 52 equals c squared. If I take the square root of both sides, that gives me c as an approximate distance of 7.2, and we'll just say this is miles since we're talking about distance on a map. Make sure you're reading the problem, but for right now our units are not, we don't have to be super specific about our units since I did not specify in the directions. Okay. Our last example is the police station, from the police station to the house. So the police station is our badge here, and the house is a house. So we are going to find the diagonal distance between the two. So first find your vertical distance and your horizontal distance. So the horizontal leg is 2, the vertical leg is 8. So 2 squared plus 8 squared equals c squared. 2 squared, 2 times 2 is 4, plus 8 times 8 is 16, equals c squared. 4 plus 20. Oh my goodness, it is too late for me to be making that mistake. 8 times 8 is 64. So 64 plus 4 is 68, equals c squared. And we need to take the square root of both sides, and c is going to be approximately 8.2 miles between the police station and the house. Okay, I know that lesson went relatively quickly. However, because of your knowledge of the Pythagorean theorem, I am hopeful that this learning target will not be too much more complicated than what we've already been doing in class. If you have any questions, make sure you ask, and you can work on the practice now. Thanks. Bye.